Hey guys, today I'm explaining the difference between layer 4 and layer 7 in routing, specifically in Kubernetes. This is really important to know if you're architecting any new systems, you want to know the traffic coming in, how you want to route that traffic, because especially on scale, it's really valuable to know how you, how your users are going to access your application and how fast or slow they want to access your application, how easy it is for them, especially in a environment where you have tons of applications running and services. So, an introduction, what is layer 4 and layer 7? Layer 4 and layer 7, I'm referring to our network layers. Layer 4 is the transport layer, and it basically routes traffic based on the TCP and UDP port and given the IP address. That's all the information it has, and then they are routed by a load balancer, typically in Kubernetes. This is a service type load balancer, and it routes traffic to a pod. Layer 7, on the other hand, is the application layer. It uses HTTP protocol to route traffic. So the benefits of HTTP, it has so much information. You have the HTTP header, the cookies, the URL, the path, and much more information to route this traffic. The benefits of layer 4, on the other hand, is that it is very fast and it's cheaper. So we'll get into why that is. So starting with layer 4 routing, as I mentioned, runs on TCP UDP. This forwards packets by the IP address and port. This is really good, especially in an environment like a trading platform or a gaming system where we need super fast and efficient traffic. So a user, when they access the application in a trading or gaming app, should be very speedy requests, right? So time-sensitive workloads, you would say. The reason why it's very fast is because there's much less overhead and latency. So meaning, unlike HTTP, all it really contains is IP address and port. There's not all this information that's adding more latency. Kubernetes services, these are cluster IP node port and load balancer. They all use layer 4 routing. Now for layer 7, on the other hand, as I mentioned, low latency use cases. I use layer 4 routing with TCP UDP when minimizing per packet processing is critical. Layer 7 and service mesh. Getting into layer 7, in Kubernetes, layer 7 routing is typically an Ingress resource. Like I said, it has a lot of HTTP information to route traffic, headers, host name, path, and then when traffic comes in, we can intelligently route our traffic. This comes really handy, especially on scale. Say a certain path like /watch or /route, we can use Ingress to direct those packets to a specific server. And then service mesh, on the other hand, this is a pretty new concept in Kubernetes. It basically adds a sidecar container beside every pod. So Ingress and layer 4 routing we were talking about is basically routing traffic inside the cluster with using load balancer or Ingress resource. Service mesh is east, we call this east to west between internal services. For example, you have a new user comes into your cluster. Now we want to route that traffic to the authentication service, and then from the authentication to the order service, we'll probably use a service mesh. Mind you, it's not necessary to have a service mesh. It does add a lot of overhead, a lot of extra latency. So we have to be careful when implementing. But in the right architecture, service mesh can really come in handy. With having that sidecar container, it provides TLS. So every internal service is now encrypted. It adds observability because we can look into every single pod and see the metrics coming in. So this is very handy for companies, right? To see the user traffic, the per latency request, see the saturation, error rates, the 4 golden signals. And yeah, as I mentioned, the trade-offs is that it's going to add a good amount of latency from extra hops and also adding complexity. Say we're looking to troubleshoot a deployment or a Kubernetes cluster. There is a lot more components going on. But yeah, in the right circumstances, service mesh like Istio would be very useful, especially in a big complex environment. Say you have hundreds of services running, service mesh might be the solution. But say you have a low latency environment or you only have a few apps, a service mesh is probably not needed. That's it. Thanks.